Hey everyone, welcome back to my channel. Let's solve some LeetCode today. In this video, we are going to solve this problem, find pivot index. Given an array of integers, nums, calculate the pivot index of this array. So what's pivot index? The pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all numbers strictly to the index right. Okay, let's clarify. If the index on the left edge of the array, then left sum is 0 because there is no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index. If no such index exists, return -1. So the pivot index is exclusive, so we don't include the index itself. Okay, so in this first example, the output is 3. So because the sum of all numbers in the left of that index 173 are equal to 11, and the elements that's coming next to that pivot index are also 11. So we are ignoring the index itself. So the first solution, brute force one, would look like this. Force. So how do we do it? So we could just iterate array for each index, compare sum of left and sum of right elements, and that would cost us time complexity would be of n squared, because we are checking each and every element for each index, and space complexity would be of 1 because we are not using any extra space. And we can optimize this by using prefix sum method. So as you can see, we are calculating sum of left side and sum of right side again and again. So we have duplicate work here. So if we analyze by using bad bottlenecks, unnecessary work, and duplicate work framework, so we have duplicate work here. We shouldn't do the same operation again and again. Instead, what we can do is we can cache our calculation and reuse the same cache. So calculate sum from left to right cumulatively and from right to left and then we could just compare. So in the third iteration, we compare the I with I plus 2 in these two arrays, so that I means the sum of values on the left, and I plus 2 means it's on the second array, and it indicates the sum of all elements that's coming right on the right of this index. So drawing explanation would be better here. So we have 173656, the first example, and So in our left array would look like this. So we have 0 for our first index, because the pivot index is exclusive, so we shouldn't include the current number in our calculation. So this would be 1. We would add this to that, and the next would be we would add 7 to 1 and get 8 and 11 and 17, and would get 22 here. And for right, we would start iterating from on rightest position. So then 6, 11, 17, and then 20 and 21. So how can we find the index that's equal, that has equal sums? So index are 1, 2, 3, 4, 5. Actually, we can just compare each index with right the same index with in the left and right. So then once we found our first equal elements on our prefix sum arrays, then we can return that index as a result. If we couldn't find any equal elements, then we could just return -1. Right? Okay. So the time complexity of this solution is O of n. So we optimize the time, but space, there is a trade-off here. Space, we are using linear space as well. So let's code this solution with prefix sum here. So the first one, left and right are equal to arrays, and for so let them be in the length of nums, and the initial value would be 0, and same for our right array. And let's iterate through nums I in range length of nums. Actually, let them start from first index and continue till the length of nums, so they're equal. So we don't touch the first index in this case. So how to calculate i's element on the left is equal to left's I minus 1. So, and we add nums I minus 1, and then this is the calculation, how calculation looks like. So for first index, we would go to the left, so it has 1 as 0 initially in here, and we would go to this value and add these two values to get our second value, and this calculates the our left array and same I in range. So this time we should iterate in reverse order, -1, and then continue till the end, and step would be -1. So writes, how to calculate writes I? So the same way, write I plus 1 plus nums I plus 1. Then iterate through both arrays. So for I in range length of nums, if left I equal to rights I, then can return I itself. So and then at the end we can return -1 here. And this is the solution that works. And can we just add this 2 fors to the one for loop, because we have already calculated writes I here and it's ready for comparison. Or let's build the right array first, because we need to return leftmost pivot index, and now we are iterating beginning from left. Then we can move this condition to here and get rid of this third for loop. So let's give it a try with the first, or let's use this example here. So 1, 2, 3. But what if we have an array with all zeros? Are we still checking that? So in this case, we are not checking the case where the pivot index is 0. So it can never be 0. So let's start iteration at 0 and add a check here. So we calculate left's I if I. So if it's 0, then we don't calculate left's I. And then this solution works. We can submit it. So we have index out of range. So why that happened? So we have started the iteration from the right side in here. So why we are getting this index out of range? We have links, so we have 6, and we have started. So this is the last index. I see. So if we don't want to start from the last index, we need to subtract 2 instead of 1. So let's submit it again. This time it works. Yeah. So in this video we have provided two solutions for this problem and implemented the more optimal one. Um, when it comes to time complexity, this prefix sum method, and this is how code looks like. Thanks for watching. See you in the next videos.